Hello there, my name is Misha. I'm a DevOps engineer from the Netherlands, and today I wanted to share with you a little project that I did recently. I really like to tinker and mess around with my home lab in my free time, and yesterday I needed a bit of a break from the grind, so I had a nice day of just relaxing and coding and tinkering. The thing is that I have this sensor. It's a Shelly temperature and humidity sensor, and I have this in my bedroom because sleep is a bit of a thing for me. If I don't pay attention, I don't sleep enough, and it's hard for me to fall asleep. So it's very important that my bedroom is on a certain temperature. At least that's what I'm trying to do. I'm not very successful because, as you can see, my bedroom tends to be over 21 degrees, which is suboptimal, but at least now I have data that confirms that. I have had this sensor for a long time, for maybe 6 months, and I used to read this data in Home Assistant. Now, Home Assistant isn't really doing it for me for some reason. I don't know why, but maybe it's the interface or the fact that it kind of feels like cheating when you can click on an integration and it's already working and poof, it's there. So and I have some problems with when I update, then sometimes I lose some data, and that's of course a skill issue, but I don't know. It's just not doing it for me. So what I wanted is to have this data in my own Postgres database, because in my home lab, I actually have several Postgres databases that I manage. If I open my dashboard here for Postgres databases, here is my comma feed database, for example, that holds all of my RSS feeds. And I have my LinkedIn database that holds my bookmarks, interface with the LinkedIn application. And what's really nice is that I can actually just see the status of my entire database. It has been backed up to the Azure cloud 2 hours ago, etc. So it's a really nice way of managing my own data. And I really started to like databases, and I'm starting to get a bit of an obsession for them. So it's nice to have my data in my own database. That's also why I want to have this very important data of my my bedroom temperature in my own database. So the way that Shelly thing works is, I'll open Excalibur here. So I have my little sensor here in my bedroom, and whenever the temperature changes with half a degree, it will wake up, and it can either stay awake and then you can curl it, but that drains the battery very quickly. I have it running on a battery. So what I do is it sends the information to an MQTT container that's running on my NAS. So I have MQ. Ooh, that is very thick. Let me see. MQTT. That is running on my Synology NAS. So this is my Synology. The Synology is in a separate VLAN. So this is in my storage VLAN, and then I have another VLAN for my Kubernetes cluster, because of course this application that I write to query this data needs to run on Kubernetes, of course. So this is my Kubernetes cluster VLAN, and this is another VLAN, and this one holds my Kubernetes cluster. So I need a way for something in my Kubernetes cluster to read this MQTT data, this queue on the container, and to put that data into a Postgres database running in my Kubernetes cluster. And for that, I thought I would need to have a container that then speaks to the database and to the MQTT container over there. So this is my database, and this is a container. This is the setup that I had in mind. And for that, of course, I thought about using Python, because I've been flirting with Go for about a year, and I know the fundamentals. I can write simple programs for it. I could have written all of this in Go, but recently I have started to turn back to Python, because that is the language that I have several years of experience in. And it is just so easy to get a project up and running with that. It is just such a, it's very easy, like mentally, to sit down and to just write something out and just get going. You can get going very quickly. And that is very different with Go. With Go, it seems to be a bit more of a, and that's of course a skill issue, but with Go, it's a bit more of a hassle to get going. And I really like the fact that I can just sit down and within 5 minutes I have something like this running already. So this was the main idea that I had, because I wanted it to run on my Kubernetes cluster, and it needed to store it in a database. Now, even though I run several databases and I've worked a lot with databases on at work, I used to take backups and dump them and restore them. But I've always been working on the operational side of databases, but I never actually took the time to look inside and to know what goes on inside of a database. So this little project also was an incentive for me to learn more about what's going on inside of a database, like how is the data actually stored? Because tables, columns, rows, all of that was still, like, I didn't really know what those terms meant in terms of Postgres databases. So I started tinkering, and I have my repo here. Oh, let me just keycaster. Let me just start my key casting here. Let's see. Keycaster, where are you? Start casting. Okay, now you see my keys, and I will just put the font size a little bit bigger. Okay, so I will go to my Git repo. This holds the code that I wrote. So it's a very simple project. It now has a Docker file, Docker compose.yaml, and a main.py. And it also has a dev container that I used to develop in. So let's see. Here you see also the .dev container directory. Now, the code itself is rather simple. This is the code. I probably won't go through the entire thing, but I set up the logging, and it takes all of the information that it needs. So it needs to know where the MQTT queue is. It needs to know which port, the username, password, and it needs the database credentials. I take all of those from environment variables. Then it needs to create a Postgres connection with those variables that you see up there. It will then set up the table in the Postgres database. So this was something new, or it was something exciting to learn about, like about different tables in databases and how you actually set up a database. And I wanted to do it from the program itself. So because I was running it in a dev container and in Docker Compose with fresh databases all the time. So all the time I wanted it to set up the table if it didn't exist. Then this is the function to insert the data into the database. This was interesting to learn about. I'm using the PsychoPG here, PsychoPG. So there are several PsychoPGs. There's PsychoPG2 and PsychoPG3. And I realized that PsychoPG3 is actually the same as PsychoPG. And this seems to be the most standard library of inserting things into Postgres databases. Because thing is, I always choose Postgres databases, always. And because that's what I have most experience with, but that's also seems to be the most common choice for databases. And there is this article that I recently read called Just Use Postgres by Ethan McHugh. Read this. It's a very interesting article, and I always did this already. I always defaulted to Postgres, but this one really confirmed my thoughts around that. So we insert the data using the PsychoPG with a timestamp. And then here comes this was a bit tricky with the MQTT connection, because basically it sets up a loop, and then it listens for certain events, and when that event happens, then it will run a callback function. So the linter here is giving me some crap because I'm not accessing certain data. I try to figure it out, but I couldn't get it to work without these errors in the linting. The code works, but I think it has to do with the nature of these callback functions, unfortunately. So we subscribe to certain topics. So the MQTT protocol works with topics. At least that's something I also learned in this process, because this is the thing. In Home Assistant, I just had a Shelly's integration with MQTT, and you click it, and then you don't really know what happens. You don't really understand what's going on. Now with this, I needed to, as I was programming this, I needed to get a sense of, which topics are there, and what do the topics look like? How does the JSON data look like? And how I'm going to pull out the data from there. And this is such a nicer experience of doing things, in my opinion. Just you ask for the data, you see what comes out, and then you pick out what you need. So this is probably very inefficient, but I like to just see in the code which topics I'm actually subscribing to. So in the main function here, it will create a connection, and then up here there is an onConnect function, a callback function. So on the event of a connection, then onConnect is being called. So in the main function, I'm starting a connection, and when that onConnection event happens, it runs this callback function, which subscribes to those topics. Now, next, there is the onMessage function. So down here, you will see there is onMessage, and whenever there is a message event, then it runs that callback function. So onMessage, it will create a timestamp. It will split the topics. It will like the data comes back in a certain format. You split it, and then I pull out the certain data that I want, and eventually I get the payload, and then I write a log line that says what it has received from the MQTT, and then it runs the insert data function to put it into the database. So far, so good. So this is this is the current state of my code. It's publicly available on GitHub. So Misha, Shelly. Here you can see the code here. This is just the current state of it as I'm recording this video. I might tinker more with this. I mean, it works now, so I might just keep it as it is. But I like to come back to these things and optimize it a little bit. But that's in a nutshell how the code works. And this took me a few hours to figure out, because I needed to learn about the MQTT. I needed to learn how this data looks like. I needed to learn about these callback functions using the PAHO library. So this is the nice thing about this. You define a use case, you define a project that you want to do, and then you figure it out. That's the goal here, to figure things out. Now, I have this code and I could run that locally. So because I was of course running this with just on my local machine with with the credentials hard coded in my file, and then of course I needed to start testing it. So then I created this Docker compose.yaml, and this Docker compose .yaml, first it builds the Docker file. We will look at that one next. But this Docker compose.yaml builds the actual Python application in a Docker image, and it sets up a database. So this is the image it will use is Postgres 16, and it takes some environment variables for the database name, the user, etc. And then there is the health check, and when that health check is completed, then because of this depends on, then the other Docker container will come up. So there's two Docker containers. There's the database container, and there is the actual Python application. That application looks like this. So I like to use the Alpine image, which is very, very basic. Then we set the work directory, we copy the requirements.txt, and then we install all of the dependencies from the requirements.txt into the container. Then we copy the SRC directory, which only contains that main.py file that you just saw. And then when the container launches, we run python main.py. Very simple. Now, this container runs as root. So that is not secure. And this is the next iteration that I'm going to do. Actually, after finishing this video, I'm going to make sure that this container runs as a different user. And then I also will update my Kubernetes manifests. So this, so far so good. I have my Docker compose.yaml, I have my Docker file, and now I can test my locally I can test whether this works by running docker compose build, docker compose up build. So this will build the Docker file that's in my current directory and all of the other dependencies that I declared. So now you see here, the Postgres database is ready. And now it has inserted some data from the MQTT queue on my Synology into the database. So we see here it is logging. So all of this is logging that we saw in the application. And now I wanted to know, like, okay, cool. I have these, like in the development process, I also needed to check out what's going on inside of the database. Now I knew how to do this with PSQL. So if I run docker ps grepdb, then here we see that my Shelly DB container, it's the first line, is already up. So if I do docker exec it Shelly db1 bash, now I'm in my container. So then in here I can run PSQL, but it is configured with a different default configuration. So what I need to do is do PSQL, and then the host is localhost user Postgres, because that is what is defined in my environment file. So now I am in my Postgres directory, in my Postgres database as the Postgres user. So if I do L, here I see the databases that are here. If I then I'm now connected to the Postgres database already. So if I run DT, then I see I have a public schema with the Shelly sensor data table. So if I want to see the data that's in the table, then I do select star from Shelly sensor data. And here we go. Here is the data that is in my database. So we see that it has a timestamp device ID, and then it sets up the temperature, the humidity, the battery, and the error. So this is all working as intended. You might think, oh, I want to have all of this in one row. And that is something I spoke at length with Claude about, Claude AI, because I when I'm coding, I use Claude a lot. And because I'm reading, my whole intention is reading this in Grafana, and then it is a time series database. And from my understanding is that it is common practice to have each metric with its own timestamp. So in this way, I can actually track, even though it's just a few milliseconds of difference, at least I know the exact moment when this metric was actually being entered into the database. So this is how this is what the data looks like. Now, another thing I wanted to do is I wanted to use pgadmin for this. I wanted to pgadmin 4. So now I have pgadmin here. This is just running locally on my macOS. But in here, just continue. Okay, so in here you have these databases. So so when you first open pgadmin, this was new to me. I had only been doing this in the CLI. But you see this local dev, you have to set up your connection. So that looks like, let's see, how can I show the connection? Properties here. So there's local dev and then the connection. And this is just local host because the container port is forwarded to my local host by Docker Compose. And then you select the parameters and you have to put in your password and then it works. Now, when you first open this, all you see is just databases and Postgres. And I had tried pgadmin in the past, but I never really understood, like, where do I actually see my data? How do I do it? So I watched a few videos, I figured it out, and now I know a lot more about what's going on, what all these things mean. So you go into schemas and then public, because that's what we saw in the CLI as well. And here again, there's an overwhelming amount of things that are in here. And I never really knew where I needed to click in order to see my data, right? Is it foreign tables? Is it aggregates? I had no idea. So then I figured out, okay, it's tables. So I opened that. And then here I see all of the different tables. And in the tables, there are columns. Now, if I want to see the data from here, I can do view, edit data. Like, it's not very straightforward. There's not like a real button here that says show data or something like that. It took a while to figure all of this out. But when I do right click on the table, then finally you see view, edit data, and I can take the first 100 rows, for example. All right, great. Now I see my data. This was something that I had learned in this process, because as I was coding, as I was developing, I didn't know, like I wrote this create table function, but I messed up a few times. I didn't know what was going where. I didn't know what a table actually was. And I needed to figure all of this out. And I wanted to see visually what was going on in my database. And this was super helpful to actually see it visually like this, because this is the first time that I actually understood that a database is actually just an Excel sheet, right? It's just, oh, a table is just a collection of columns. A table is basically just an Excel sheet in my limited understanding. So a table is a table is just a collection of columns here. Each of these is a column, and every column has rows. It's just so simple. I don't know why, but it never clicked for me until this moment, until I actually started to put things in databases myself programmatically and wanting to put things exactly where I wanted them. So again, everything is on a separate row with its own timestamp. If this is a horrible practice, please teach me. Like I'm not a data engineer. I don't know much about this and I want to learn. So if you're watching this and you're cringing because you see this, please explain to me and teach me, because the only thing that matters to me is the truth, and I always want to become a better engineer. Now, here we see that we have these entries already. So that is done by the psychopg function, and it inserts all of these things into my database. So this is the locally running database that's running on my Kubernetes cluster. On my Docker, on my MacBook, I mean. This is not running on my Kubernetes cluster. So this was already a really nice learning experience. I mean, I learned how to, let's close the Docker container now, or the Docker Compose setup. So this has already been a great learning experience, right? I learned how to set up a table on a Postgres database, what it actually means. I learned how to insert data. And again, just I needed to log these things, right? I needed to show things properly in my container logs. And like these SQL queries, I knew a bit of SQL, but now I actually know what this means. I didn't know what a primary key was, right? I had restored them at work, but I never really took the time to actually know what it was. Well, now I do. And this is what these little silly projects that seem so small can really make these things click. Like when things seem overwhelming, go to the fundamentals and then tinker with it. And this is why a home lab is so important. You tinker with things. So I have my database set up. It's running locally on Docker Compose. I had a way of setting it up because this is DevOps, right? When you're developing something, you don't just run the stuff locally all the time. No, you instantly take the time to containerize it. You write a Docker Compose.yaml. So every time you create a different you create a change, you can actually test it with a fresh database, right? You can test things. So far so good. I have a working container. I have a working Docker Compose setup. Now it's time to actually push this to GitHub. So I have this in a local repo, but you can like build the Docker image locally and push that, but that's not very DevOps, right? So what we do is we set up a workflow.yaml. So this is a GitHub Actions workflow. This is for free. And what it does is, if I go to my Shelly repo, we see here that I have tags here. Tags. And these tags are generated automatically based on the conventional commits that I push to this repo. If you don't know what that means, look up conventional commits. It's a standard of how to formulate your commit messages. And then this GitHub Actions will push a package to the GitHub container registry, Shelly, and with the latest tag like this. So how do we do this? Well, we need a way to automatically increment the tags based on the commit message. For that, you use this GitHub action, the semver action. This will get it defaults to the patch version, so the last digit in the 0.0.0. And whenever I run a feed commit, then it will upgrade the minor version. And then eventually when I do a breaking change, that's when I have to do a feed exclamation mark, I believe. That's when it will upgrade the major version. So it increments the tag, it pushes the new tag to the repo, and then it simply logs into the GitHub container registry using my GitHub token. This is just a standard variable that's available in every repo. And then we simply just build the container image based on a Docker file, and we push that to my own GitHub actions, to my GitHub container registry on my own username. Very easy, but appended with the semantic versioning as a tag. So that is really cool. Now we have our container image being built and pushed to GitHub. Now the next part comes with getting it into my Kubernetes cluster. For that, we go to my Homelab repo. So this is my Homelab repo. It contains all of the GitOps configuration for my Homelab. And if you want, like, if you are interested in setting up your own Homelab and finding a community with other people who are interested in Kubernetes Homelabs, you need to take a look at my KubeCraft school community, because this place is a fantastic place to network with like-minded engineers. We are all posting new suggestions and new applications, new things about Homelabbing, about improving your career, which certifications to get. We're all about Kubernetes and DevOps and Linux, and it's just a great community to network. And when you become a member of this community, you also get unlimited access to all of my courses about Kubernetes, about Linux, about note-taking. It's a great resource. It's only $35 a month. You won't regret it, seriously. And you can cancel anytime. The best place to network with like-minded individuals is here, and you can get help with setting up your Homelab. So, in my Homelab repo, I have all of my GitOps configuration. So what this means is that I have Flux running on my Kubernetes cluster, and that is constantly monitoring my Homelab repo for changes. And whenever it sees a change, it's going to deploy the resources on my Kubernetes cluster. I don't apply things to my cluster. Flux does that for me. It's all automated. So I needed to set up my database on my Kubernetes cluster, because I run databases in Kubernetes. I don't run databases elsewhere. It's all in my Kubernetes cluster. So to do that, let me show you the configuration I created for my Shelly setup. So first, we have a customization.yaml. It looks at base Shelly, and then it loads these YAML files. And this is all available for free in my public repo, michavandenberg/Homelab. So the database.yaml is done with the enterprise DB operator. This YAML, I'm going to be creating a course on the EDB operator in this winter. So if you are interested in that, stay tuned. But this sets up the database in my Kubernetes cluster, and it sets up an automatic backup to Microsoft Azure. So all of my databases are being backed up to Azure every night, and it's all stored in storage accounts. Now, I won't go through all of the details of this configuration because it's quite complicated, but what I will say is that I store all of my credentials in Azure Key Vaults. And in order to do that, I have a utils script here in my Homelab, and there is another Python script that will create all of the secrets in Azure in the Azure Key Vault, and then also generate the database manifests here that you see here. All of this is generated by Python. This manifests I'm deploying so often that I automated that process as well. So this is automatically generated by Python. So we have the database.yaml, and we have a scheduled backup for said database. Now, as we saw in the customization.yaml, it looks at the base Shelly directory. So here we have base, and then we have Shelly. And here we have a deployment.yaml. So this just simply takes that image that we saw in the GitHub Actions. This is the same name, but it also appends the version, and I will come back to it. We read the config map and the secret ref. So I have a secret that is being created from the Azure Key Vault secrets using the Azure Key Vault operator, then it reads out the values from the Azure Key Vault, and then it creates secrets based on that. So I have my deployment here, and it just simply reads in the config map, which contains a key value pair, a few key value pairs with the location of my MQTT broker, and which Postgres host it needs to connect to, etc. And of course, it needs to read in the secrets that I just showed you. And that's it. And then it just, the way these CSI secret drivers work is that you have to mount them into the container in order for them to be available as environment variables as well. So that's what I do here too. So here the container is, it's a very simple deployment that just takes the container image that I built. Now the cool thing is, when I deploy this, this is now being deployed by Flux. So if I go to my, here, I can do Flux get customizations. This FGK is a shorthand for Flux get customizations. And all my customizations are in order right now. Now let's see this workflow at work. So let's go to my Shelly repo. And there was actually a bit of a small mistake in my setup. I was using Postgres 13 and I needed to update this to 16. So I'm going to commit this change to my main branch. And yes, I could create a pull request and then merge that. But since it's just me working on this project, I have no problems with committing straight to the main branch. So let's first do a git pull. And then my YubiKey is prompting me to see if I'm actually allowed to do that. And yes, I am. So then let's commit this and say chore update Postgres version in Docker Compose. So now I have a chore commit, and since it's not a feed commit, now the GitHub Actions should only upgrade to v1.2 because it's not a minor version. So I push this, and if I go to my repo now, Shelly, if I go to actions, now we should see, yes, we see a GitHub Actions flow running. And let's see, oh, it is already finished almost. So it's now actually building and pushing. So that is really good. It's now building the Docker image and pushing a new tag. So let's see what the new tag is. Did that work properly? Let's see. It checks out get next version. Let's see what that looks like. Comparing against latest tag v01.1. And then the next version is 0v1.2. So it is actually detecting the correct version. It's upgrading the version automatically. And now it's pushing the new version of this container image to my GitHub container registry. Really cool. So even though this is not an actual change to my application, it still increased the version, right? But that gives me a chance to actually demonstrate how I upgrade things in my Kubernetes cluster automatically. So if I run K9s now, I will see here all. These are all my pods that are currently running. And in my cluster, I run renovate. And that is running as a cron job. And that has last run for 27 minutes ago. So if I go to my Homelab repo, and if I check out my pull requests, here we see that their renovate creates pull requests for me that upgrades or that will change the version, the newer version that it finds on GitHub. This is the power of GitOps. This is why you want to run stuff with GitOps, because I don't need to track updates, right? Renovate does that for me. So let's do that. I have this cron job, And then I'm going to press T to trigger that cron job. So if I see it here, if I go to all namespaces and back to pods, now here I see this manual job running now. I can log it, and these are the logs that you see from my renovate pod that's now running. And now we should see a new update for Shelly. And I think I saw it already. Yeah, here we go. PR title, PR created, update Misha Vandenberg Shelly to Docker tag v01.2. Pretty cool. So if I go to my pull requests again, we see indeed we now have a new update of this Shelly Docker tag. And when I go in here and I merge it, Flux is going to pick up this change. So before I merge it, let's just check out what's running now. So we see our Shelly pod over here. This is now running in my Kubernetes cluster. And when I press L, it shows the logs that it has been inserting into the database, right? So the last insertion is, let's see, the last temperature that it has entered is 23.6 degrees. So let's check out our Grafana here. And now we see, because I'm sitting in this room with my door closed, we see that the temperature has risen a lot. It's actually almost 24 degrees in this room, apparently, because the sensor is here with me. And my office tends to be a bit warmer when I close the door because of the road noise that I don't want when I'm recording. So we see that it's working, right? It's actually updating live. Now, let's merge this pull request. We're going to merge it, confirm, and let's delete the branch. So now when I do to speed, like usually it takes a few minutes for Flux to pick this up, but what I will do is I'm going to just run a reconciliation apps with source. And now I can, if I run a watch, now we can see in live what is happening, right? So it's now reconciling all of these customizations that I have. And I have several because, let me see, let me just move to a smaller font size again. Here, now you can see it a little bit better. It needs to cycle through all of these different customizations that I have. So I have private resources that are deployed through a private repo. It has all of the monitoring. It has the infrastructure. And then last comes the apps. It all depends on these different things because my apps because the infrastructure needs to be there before we before we can deploy the apps. So let's see if we should see a new pod being started very soon here. The Shelly pod is here now running with an age of 12 hours. And yeah, here we go. Here's the new container creating. It's pulling the new image. And here we go. We have it running. It's now terminating the old one. And let's check out the logs. It's now inserting the data again because it will actually take the latest stuff from the MQTT sensor. And now it's actually 24.25 degrees in my office over here. It's actually very warm. So, and if I refresh here, then we should see, yeah, here we see the new data point in my in my Grafana dashboard already. Super cool, right? I mean, yeah, I'm really excited about this. I love this stuff. I can just push I can push a change to my Git repo. It automatically builds the new container with a new tag, and then my renovate will pick up the new tag, and by just merging a pull request, it deploys the new version of my application into my cluster. This is why you want to run Kubernetes, And this is why you want to run GitOps. It's fantastic. So we have our Grafana dashboard, and now this is running in a database, right? So if let's check out the data namespace. So here we have my database running in Kubernetes, and the EDB operator runs it in 3 replicas, and we can also check out the database itself in Grafana. So if let's see here, now I have my data. This is the actual database that we queried when we show this temperature graph that we just saw. This is the actual, these are the stats for that database, and it's actually using quite a lot of memory. So maybe I should increase the memory for that. But here we see all of the good stuff. Everything is working properly. So what I can do is I can either shell into my database, PSQL, and maybe I should increase the font size again. There we go. So here I have my Postgres, and here I see the Shelly database. So I have to connect to Shelly. And if I list the tables here, I see the Shelly sensor data. And if I then select star from Shelly sensor data, select star from Shell. There we go. Now we see all of the data that's in that table, right? So that is how I can query it, but I also wanted to use pgadmin there. Now I could connect with my local pgadmin, but I wanted to do something fun. And as you might have noticed, there is a pgadmin container running in this data namespace. Since I'm running several databases on my cluster, I thought it would be handy to just run it on my cluster too. So if I check out my home page here, then in the left you will see a pgadmin. So I open that one up, and here is my pgadmin that is running in the container on my Kubernetes cluster. And it's directly connected to my database there. So I've only configured it with this server here, but I can add all the servers that I have in my Kubernetes cluster. But if I check out the columns, or if I just check out the data here, and view edit data, and I can see all of the rows in my actual production database of Shelly. So these are all the data points that you see in Grafana that it has stored so far. Now, how do I get this stuff into Grafana, right? Well, not surprisingly, Grafana is running in my Kubernetes cluster. So what I can do is I can add data sources here. And these data sources are basically just the connection info to the databases that are running locally on that Kubernetes cluster. So I just use a Kubernetes DNS formatted domain to reach the service that the EDB operator exposes for these databases. And when I added this data source, then you can just query it using PSQL queries. So when I go to my bedroom temperature panel here, for example, when I edit it, what you see here is just a SQL query. That's it. You just query SQL, and then you visualize it in Grafana. And this is why it's so nice to have your data in your own Postgres databases instead of Home Assistant and no. Here I can just actually write the code that I want to see. I've written the code that puts this into the database. I know exactly what the database looks like, which columns are there, which tables are there, where to look, and I can decide which data I pull out in which manner. And this is so nice. If I can, I'm going to avoid Home Assistant and just store everything in my own databases, because then I can control the database. I can fine tune it when I need to have more performance. Like for this is ridiculous. It's just nothing. But when these things grow, I want to have the control over the database, right? I can choose to back everything up. Like if am I logged in? Will this work? In Azure, I have my storage account here. And if I go to the storage browser and I go to my blob containers, all of these databases are stored in my Azure account. And these are backed up once a day. So when I want to restore with the EDB operator, I can just point it to this data that's stored in the Azure cloud, and it will restore from there. So if my house burns down, I know exactly, I know that I can restore everything from the cloud whenever I want to. It's just so fantastic. And this only costs me like $12 a month, 12 cents a month, not dollars. It's just because it's so small, it doesn't cost anything. So all of this is working, and it's being backed up. I can check the data with pgadmin in the cluster. It is queried with Grafana, and that is how I have managed to read the sensor data from this thing in my Kubernetes cluster and query it with Grafana and have full control over my data. Everything is being deployed with Docker Compose. It builds the image automatically, and this is the DevOps way to do it, right? You want to automate these things. Now, there's so much more I can do. I can do more Python testing. I can do pre-commit hooks. I can make sure that my images do not contain CVEs. The first step is actually to first update my Docker container, and then, which I'm going to do after this video, and then I'm going to add a security context here, because it should not run as the root user, it should run as the user that I configure in my Docker file, etc. So there's just, even with a silly project like this, with a Python file that is like 50 lines long or whatever it is, you can go so deep and you can learn so much. I've learned how to query JSON data, how to pick it up, how to interact with MQTT, how to store this stuff into databases. And this is the power of project-based learning. You define a small little project for yourself that you want to do. For me, it was, I want to have this data in my own Postgres database so I can query it with Grafana. And then you learn so much. You have to learn about databases. You have to learn how to set up a Docker Compose, how to set up Docker, how to set up your GitOps actions. And I learned that in a previous project, and I could just pull that into this project. That didn't take much time. So in summary, this was a very fun day of tinkering yesterday, a fun day of coding. I have achieved what I wanted to do, and I have acquired a taste for more. It's so much fun to write your own code and deploy it in your own cluster. I highly encourage you learning this, because all of this transfers directly to my work as a DevOps engineer. It's all practice. It all contributes to becoming a better engineer. So this was an example of how I approach projects, and maybe it's an inspiration for you to start doing your own projects. It all starts with a Homelab Kubernetes cluster. I'm currently working on a course for that. And so if you're interested in that, join the school community before the price increases. I highly encourage you to come and ask for help there, because we're all about the same thing. I will help you set up your Kubernetes laptop, your Kubernetes Homelab on a laptop if you want. And you can start tinkering from there. So thank you so much for watching, and I'll see you in the next video.